Okay, so let's start with the fourth tutorial of machine learning. Now here we are going to discuss the random forest. So what is random forest? Random forest or random decision forest are an ensemble learning method for classification, regression and other tasks that operate by constructing a multitude of decision trees at training time and outputting the class that is mode of the classes or classification or mean average prediction. That is what the random forest is. Now random forest is a supervised learning algorithm and it can be used both for classification and regression purposes. It is also the most flexible and easy to use algorithm. A forest is comprised of trees that we already know. It is said that the more trees it has, the more robust a forest is. So a random forest creates decision trees on randomly selected data samples, gets prediction from each tree and selects the best solution by means of voting. It also provides a pretty good indicator of the feature performance or feature importance. Now random forest has a variety of applications such as recommendation engine, image classification and feature selection. It can be used to classify loyal loan applicants, identify fraudulent activity and predict diseases. It lies at the base of the Borutal algorithm, a wrapper built around the random forest classification algorithm, which selects important features in a data set. Now the random forest algorithm if you want to understand in a layman's language, it is suppose you want to go on a trip. All of us go on a trip for a vacation or something. So suppose you want to go on a trip and you would like to travel to a place which you will want to enjoy. So what you will do? Find a place that you will like to go. Then you can search online, read reviews or travel blogs and portals, etc. Or you can ask your friends. Now let's suppose that you have decided to ask your friends and talk with them about their past travel experience to various places. You will get some recommendations from every friend. Now you have to make a list of those recommended places. Then you ask them to vote or select one best place for the trip. From the list of the recommended places you made, the place with the highest number of the voters will be your final choice for the trip. Now in the above decision process, there are two parts. First, asking your friends about their individual travel experience and getting one recommendation out of the multiple places they have visited. So this part is like using the decision tree algorithm. Now here, each friend makes a selection of the place he or she has visited so far. The second part, after collecting all the recommendation, is the voting procedure for selecting the best place in the list of the recommendations. The whole process of getting recommendations from friends and voting on them to find the best place is known as the random forest algorithm. So how easy it is to understand with this example now. So it is technically in an ensemble method based on the divide and conquer. So you can divide and conquer. So then you will come out with a choice which may be appealing to you. And it is the decision trees generated on a randomly split data set. Now this collection of decision tree classifier is also known as the forest. Now the individual decision trees are generated using an attribute selection in indicators such as information gain ratio and Gini index for each attribute. Each tree depends on an independent random sample. In a classification problem, each tree votes and the most popular class is chosen as the final result. In the case of a regression, the average of all the tree output is considered as the final result. It is simpler and more powerful compared to the other non-linear classification algorithm. Now how does it work? It works in 4 steps. Select random samples from a given data set, construct a decision tree for each sample and get prediction result from each decision tree, perform a vote for each predicted result and then select the prediction result from with the most votes as the final prediction. So you can see with this picture tells you that whatever data that you have gathered for this kind of a analysis, you will see that you can divide it into training set and test set, and then you can develop your decision tree with the algorithm that we have discussed, and then you go for the voting, and then finally you go for the prediction. Now, advantages with this is that random forest is considered as a highly accurate and robust method because of the number of decision trees participating in the process. It does not suffer from the overfitting problem also. The main reason is that it takes the average of all the predictions. Each cancels out the biases. So there is no bias left. The algorithm can be used in both classification and regression problems. Random forest can also handle missing values. There are two ways to handle these: using median values to replace continuous variables, and computing the proximity weighted average of missing values. So whatever suits you, you can apply that. You can get the relative feature importance, which helps in selecting the most contributing feature for the classifier. Disadvantages: like random forest is slow in generating prediction because it has multiple decision trees. So that is the reason why the process gets slightly slower. Whenever it makes a prediction, all the trees in the forest have to make a prediction for the same given input and then perform voting on it. The whole process is time consuming. Now, the model is difficult to interpret compared to decision tree, where you can easily make a decision by following the path in the tree. Now that's how the random forest process goes. Now let's talk about another method, that is naive Bayes. Now naive Bayes is a classifier. It is naive because it makes the assumption that features of a measurement are independent of each other. This is naive because it is almost never true. What is naive Bayes? Naive Bayes is among one of the most simple and powerful algorithm for classification based on bias. Now, based on Bayes theorem with the assumption of independence among predictions or predictors. Naive Bayes model is easy to build and particularly useful for very large data set. There are two parts of the algorithm. One is naive, the other is Bayes. Now, naive Bayes classifier assumes that the presence of a feature in a class is unrelated to any other feature. Even if these features depend on each other or upon the existence of the other feature, all of these properties independently contribute to the probability that the particular fruit is an apple or an orange or a banana, and that is why it is known as naive. Let's move forward with the naive Bayes. Now, what is Bayes theorem? In statistics and probability theory, Bayes theorem describes the probability of an event based on prior knowledge of conditions that might be related to the event. It serves as a way to figure out conditional probability. Given a hypothesis H and evidence E, Bayes theorem states that the relationship between the probability of hypothesis before getting the evidence, that is PH, and the probability of the hypothesis after getting the evidence, so PH/E. So this is the formula for that. Now this relates the probability of the hypothesis before getting the evidence to the probability of the hypothesis after getting the evidence. That is why PH/E. For this reason, it is called the prior probability, while PH/E is called the posterior probability. The factor that relates to the two, that is PH/E divided by PE, is called the likelihood ratio. Using these terms, Bayes theorem can be rephrased as the posterior probability equals the prior probability times the likelihood ratio. This completes the naive Bayes and the reforest also. And so the fourth tutorial is over, so we are going to go for the next tutorial. Thank you.